Welcome to my algebra class. We are on chapter 4, section 4. We're working with taking a power of a power. The example here has 3 to the second power taken to the fourth power. Remember, an exponent tells you how many times you use the base, and the base is 3 to the second, so we use it 1, 2, 3, 4 times. And each one of those is 2 3's. So if I add them up, I get a total of 2 plus 2 plus 2 plus 2, which is 8. And instead of doing that every time that I have a power of a power, notice that the 8 is the same as taking the 2 times the 4, multiplying the exponents. So our rule for finding the power of a power is, if the bases are the same, multiply the exponents. And the other type of problem you will see in the second set of problems is the power of a product. And by that we have a product inside the parentheses, the -3 times m to the second n to the fourth. And we're taking the whole product and taking it to the third power. So that means each part of the product, each factor, is taken to the third power. So the -3 is taken to the third, the m to the second is taken to the third, and the n to the fourth is taken to the third. So -3 to the third would be -27. Since I used the -3 3 times, it's going to be negative. M to the second taken to the third, multiply your exponents, you get m to the sixth. And n to the fourth taken to the third, multiply your exponents, since it's a power of a power, you get n to the 12th. And the rule here is to take the power of each factor. So a couple more examples. X to the third taken to the fourth. You would multiply your exponents to get x to the 12th. This is a power of a product. Everything inside is taken to the third power, so that would be m2 times 3 is 6, and 5 times 3 is 15. And the last example, 2 to the third power, x to the third taken to the third, y to the fourth taken to the third. So that would be 8, x to the 9th, y to the 12th. And this is what's on your paper for your vocabulary. Power of a power, if I have a power a to the m and I take it to the nth, this is the formal rule. It's a to the mn, multiply your exponents. And if you have a product taken to a power, product is represented by ab, power is m, and each part inside is taken to that power, so a to the mth, b to the nth. That concludes the explanation of the section. You need your notebook paper, and make sure it's folded in half, and your heading and your title. And we're going to start on page 150, which has some problems to do, and then we'll get into the work that was mentioned in the earlier. So on page 150, we have 10 word problems. Problem number 2 says write the sum of the areas as a polynomial in simplest form. So we're going to take each rectangle and find its area. So the first rectangle, the purple one, we take 5x times x. And then we're going to add that to the next rectangle, whose length and width are 2, so that'd be 2x. And then the green one, 3 times 5x. And finally the yellow one, which is 3 times 2. So multiplying that out, I get 5x squared, x times x is x squared, plus 2x, plus 3 times 5x is 15x, plus 6. Collecting like terms, 5x squared plus 17x plus 6. This is actually a physical method of doing FOIL. Number 4, the orange rectangle is 2x times x, its area, plus the green, 3 times x, plus the blue, 2 times 2x, plus the pink, 2 times 3. So we get 2x squared plus 3x plus 4x plus 6. Collecting like terms, we have 2x squared plus 7x plus 6. Problem number 6, it says find 3 consecutive integers whose sum is twice the cube of 5. Well, we're talking consecutive integers, so we're going to represent them, and they want the 3 consecutive integers. So x equals the first integer, x plus 1 equals the second, and x plus 2 is the third consecutive integer. And they want the sum to equal the square of 6. So if I add these together, I get 3x plus 3. And the sum equals the square of 6, which is 36. We have a 2-step problem, so solve it and do addition. So we subtract the 3. And we get 3x equals 33. Divide by 3, and x equals 11. So my 3 integers are 11, the next one is 12, and the next one is 13. And if I add them, they add up to 36, so it does work. Problem number 8, find 2 consecutive odd integers whose sum is the cube of 4. So going back, it's consecutive odd, so x equals the first odd integer. Odd integers go up by 2, so x plus 2 equals the second odd integer. And they said their sum, so add them together, 2x plus 2, is the cube of 4. And the cube of 4 is 64. So solving for x, subtract the 2 from both sides and do addition first. We get 2x equals 62, divide by 2, and we get x equals 31. And they said find 2 consecutive integers, so it'd be odd, be 31, add 2, and 33. And if I add them together, I get 64. Problem number 10. The greater of 2 consecutive even integers is 10 less than twice the smaller. Find the integers. This time we're working consecutive even integers, so x equals the first even integer. And the next even integer would be x plus 2. And it said the greater of the 2, which would be the x plus 2, is 10 less than twice the smaller. So take twice the smaller minus 10. We have variables on both sides of the equation. We want to get the variable on one side, so I'm going to subtract x from both sides. So now I have 2 equals x minus 10. Solving for x, undo the subtraction, add 10. I get 12 equals x. So the 2 integers would be 12 and 14. And I can check it. The larger is 10 less than twice the smaller. So twice the smaller would be 24, 10 less makes 14. It works. The other part of your assignment is on page 156, so turn to that now. And we're doing 1 through 50. So problem number 2. We're to evaluate each of these A, B, and C using x equals 3 and y equals 2. So a, substitute the value in for y, which is 2, and we're squaring it. So that would be 5 times 4, which makes 20. Part B, I'm going to skip a line between these. We have parentheses 5 times 2, and we're squaring that. So that would be 10 squared, which is 100. And part C, we have 5 squared times y squared, which was 2 squared. So that's 25 times 4, which makes 100. Problem number 4, A, it's xy cubed, so that'd be 3 times 2 to the third power. We do the power first, so it'd be 3 times 8, 2 to the third is 8, which gives us 24. Skip a line. B, we have the quantity, x times y, 3 times 2, taken to the third power. 3 times 2 is 6. We're going to take it to the third power. If you don't know what the third power of that is, find your calculator. So 6 to the third power is 216. C is x cubed, so that'd be 3 cubed times y cubed, which is 2 cubed. 3 cubed is 27, and 2 cubed is 8, and 27 times 8, I think we can do this without a calculator, that's 56, carry the 5, 16 plus 5 is 216 also. And actually that's following the rule of a power of a product. Each one inside gets taken to that. So they're the same. Number 6, we have A, which is x to the 4th times x to the 7th. Since we're multiplying powers, the rule is to add the exponents. So 4 plus 7 makes x to the 11th. Skip a line. We have x to the 4th taken to the 7th. This is a power of a power. This time we multiply the exponent, so that's x to the 28th. This is where you've got to distinguish whether you're multiplying two powers or taking a power of a power. Here we add, here we multiply. C, we have x to the 7th taken to the 4th. This is a power of a power, so we times and we get x to the 28th. Problem number 8, A, we have negative 2k to the 5th, and we're taking that to the 6th power. So everything inside is taken to the 6th power, so the negative 2 is taken to the 6th, and then k to the 5th is taken to the 6th. Negative 2 to the 6th power, we've already seen the 6th power back here. Well, maybe we haven't. Okay, let's go. Get the calculator. 2 to the 6th power is 64. And it's a negative 6 times, so it's going to be positive 64. Multiply your exponents k to the 30th, since you're taking a power of a power. Skip a line B, you have the opposite of 2k to the 5th taken to the 6th. So that's the opposite of 2 to the 6th power times k to the 5th taken to the 6th. 2 to the 6th power we know is 64, and k to the 5th taken to the 6th is k to the 30th, so it comes out negative k, 64k to the 30th, since the negative sign was not part of the product. And C, we have negative 2 times k to the 5th taken to the 6th. So do the power of the power, and we get negative 2k to the 30th if we multiply the exponents. Problem number 10, we have negative 2t, the product to the 5th. So everything inside is taken to the 5th power. So negative 2 to the 5th, and then t is to the 5th. Negative 2 to the 5th power, 2 to the 5th power is 32. And it's 5 negatives, so that would be negative 32t to the 5th. Problem number 12, we have 5x taken to the 3rd power. So that's 5 to the 3rd power and x to the 3rd power. 5 to the 3rd power is 5 times 5, 25, times another 5 is 125, x to the 3rd power. Problem 14, we have 6x to the 3rd taken to the 2nd, so that's 6 to the 2nd power and x to the 3rd taken to the 2nd power. 6 to the 2nd power is 36. Multiply your exponents, that's x to the 6th. Problem 16, we have the quantity negative 2t to the 4th taken to the 4th power. So that's negative 2 to the 4th power times t to the 4th power taken to the 4th power. 2 to the 4th power is 2 times 2 times 2 times 2, which is 16, and there's 4 negatives, so that's positive 16. And then multiply your exponents since you're taking a power of a power. That's t to the 16th, 4 times 4. Problem 18, 2x squared y, and you're taking that product to the 5th power, so everything inside is taken to the 5th power. 2 to the 5th times x squared to the 5th, and then y to the 5th. So that comes out 2 to the 5th power is 32. X, 5 times 2 is 10, and then y to the 5th. And problem number 20, we have 5p cubed, q to the 4th, taken to the 3rd. Everything inside taken to the 3rd power, so it's 5 to the 3rd, times p to the 3rd taken to the 3rd, and q to the 4th taken to the 3rd. 5 to the 3rd power is 5 times 5 times 5, which is 125. Multiply your exponents, that's p to the, 9th. I just accidentally did something I shouldn't have. That should be 9. 3 times 3 is 9. And 4 times 3 is to the 12th. Next section, we're multiplying powers of products. So it's going to get a little bit more complicated, but not that bad. 22. We have 3c to the 2nd power, the product, times 3c to the 3rd power. Everything inside is taken to the 2nd power, so 3 squared times c squared. Same here, 3 cubed times c cubed. So that's 9c squared. 3 cubed is 27. C to the 3rd. So 9 times 27, if you need your calculator, you can get it, is 243. Now here, be careful. C squared times c to the 3rd. We're multiplying two exponents, the powers together. So this is where we just add the exponents. I have 2 c's here, 3 here, so it's c to the 5th. So all the rules have been used here. Power of a product, and then multiplying two powers together. 24. We have 1/2 y taken to the second power times the quantity 2y taken to the fifth power. This is 1/2 squared times y squared. And this is 2 to the fifth and y taken to the fifth. One half times 1/2 is 1/4. That's y squared. 2 to the fifth is 32. Y to the fifth. If we put the 32 over 1, we can cancel the 4 with the 32. And we get 8y. Now remember, you're multiplying two powers together, so you add the exponents. 2y's here, 5y's here. That's y to the 7th. So our answer is 8y to the 7th. Problem number 26, I have the quantity 2x squared y cubed taken to the fourth times the quantity negative xy squared taken to the second. Everything inside is taken to the fourth power. So 2 to the fourth, x squared to the fourth, and y cubed to the fourth. Minus times, let's change that a little bit, a negative x to the second and y squared to the second. 2 to the fourth is 16. X squared taken to the fourth, multiply your exponents, is x to the 8th. Y to the third taken to the fourth is y to the 12th. A negative x squared is just x squared, since you use the negative sign twice, and then y to the fourth. All right, the x to the 8th and the x to the second, you might multiply those together. You can add your exponents, so that's x to the 10th. Y to the 12th times y to the 4th is y to the 16th. Number 28. I have 1/10 x cubed y taken to the third times 10y to the fourth. So everything inside is taken to the third power. So 1/10 to the third, x cubed to the third, and y cubed. Here everything is taken to the fourth power, 10 to the fourth, y to the fourth. 1/10 times 1/10 times 1/10 is 1/1000th. X to the third taken to the third is x to the 9th, y cubed. 10 to the fourth power is 10,000, and then y to the fourth. So we could cancel the 1,000 and with the 10,000 get 10. So we have 10, there are no other x's, x to the 9th, but the y to the third and the y to the fourth would add up to y to the 7th. So our answer is 10, x to the 9th, y to the 7th. Problem number 30. We have a nested grouping, the brackets, then we have the opposite of x cubed, then squared, then cubed. And to do these, you have to work from the inside out. So you take negative x cubed and you square it first. So that gives you, since your squaring is going to come out positive, because there's two x's, x to the 6th, and then you take that to the third, which gives you x to the 18th. Multiply your exponents. And 32, you have 5a squared b, that product squared, and the product 5b cubed. Everything inside is squared, so 5 squared times a squared taken to the second, and b squared. And the second product, the 5 is cubed, and b cubed. Everything inside taken to the third. 5 squared is 25. A to the second is a to the fourth. B squared. 5 to the third is 125. B cubed. So 25 times 125 is 3,125. And you have a to the fourth, b to the second, b to the third, add the exponents, b to the fifth. We're going to skip 33 through 38, and we're going to finish 39 through 50. So we're on number 40. This is a to the x taken to the third power. So you multiply your exponents, that's a to the 3x. 3 times x. 42, you have x to the nth times x to the second. This is multiplying two powers together, and we add our exponents. So it's x to the n plus 2 power. 44, we have a to the x times a to the x times a to the x. Multiplying powers, we add the exponents, so it's x plus x plus x, which equals a to the 3x. 46, we have a to the x taken to the y power times a to the y taken to the x power. So this is a to the xy power times a to the yx power, which is the same as xy. So now since the bases are the same, we can add the exponents. So it's a to the xy plus xy power. That's 2xy's. So it's a to the 2xy. (48), we have 2x to the nth power taken to the third, and x to the nth taken to the fifth. Everything inside is taken to the third power. And here it's just multiply your exponents, you get x to the 5n. Here we have 2 to the third, which is 8. Multiply your exponents, we have x to the 3n times x to the 5n. Okay, so that's 8 to the times x to, we could add our exponents, 3n plus 5n, which gives us 8x to the 8n. And the last problem, number 50, we have t to the nth power taken to the nth times 3t to the nth taken to the nth power. Multiplying our exponents, this is t to the mn power times 3, multiply again, t to the mn power. And get them in alphabetical order. So that's 3, and we can add our exponents, mn plus mn, because we're multiplying two powers, which equals 3t to the 2mn. That concludes the evens. As you do the odds, be sure and check your answers at the back so you know if you need to get help, if you can't figure out how to get that answer. Good luck.